In this lecture, I'm going to talk about the resistor. The resistor is an electrical component that reduces the electric current and voltage. In other words, it has a specific, never-changing electrical resistance. The resistor resistance limits the flow of electrons through a circuit, and its resistance measured in ohm. So that means that the resistor is an electrical component, okay? This component reduces the electrical current and the voltage. So that means that this component reduces the value of electric current and voltage. In other words, we can say that this resistor has a specific never-changing value of resistance, of electrical resistance. This electrical resistance, or this value of electrical resistance that exists inside this resistor, limits the flow of electrons through a circuit. So that will make the voltage and the current, or that will reduce the value of the voltage and current. This resistance measured in ohm, as we know. Section 1 talks about the types of resistors. Bands. Before we begin explaining the types of resistors, we must know what is these bands. These colors that exist on the body of the resistor are called bands. From these bands, we can calculate the value of the resistor using a table with a specific value for every color. Which means that from these colors, or from these bands, these lines, the one line called band. So these 4 lines, or there is 5 lines or more. So these lines are called bands. From these bands, we can calculate the value of resistor using a table. In this table, there is a specific value for each color. There is 4 types of resistor. First one is the 4-band resistor. Second one is the 5-band resistor. Third one is the 6-band resistor. Fourth one is the variable resistor. The first type, the 4-band resistor, we calculate the value by putting the first and the second digit, and then we times it with the third digit and plus or minus the fourth digit. So that means that this is the table that we are using to calculate the value of the resistor. If we have a resistor, a 4-band resistor, this 4-band resistor has 4 colors, okay? For each color, there is a value. For example, the value of black is 0. At the first band, the value at the first band is 0. The value of black at the second band is 0. The value of black at the multiplier, or the third band, is 10 power 0. At the fourth band, the tolerance band, there isn't value, or the black shouldn't be in the fourth digit, or the fourth band. So how to calculate this value, or the value of this resistor? First thing that we need to know is to put the first and the second digit. So that means that we are going to put the value of the first and the second band or digit. We can call it band or digit. And then we times it with the third digit. So that means that we will times, or we will multiply the values that we have put it with the third digit, or the third band. And then we are going to put plus or minus the fourth digit. By the way, the tolerance is the fault percentage, because the accuracy, or the value of the resistor, the resistance of the resistor is not very accurate. So the tolerance is the fault percentage of the value that comes out, or the value of the resistance of the resistor. For example, if we have this resistor, for example, this resistor has the black at the first digit and red at the second digit, blue at the third digit, and this is a silver at the fourth digit. First thing that we will do is to put the first and the second value of the first and the second color. So the value of the first color, the black, equals to 0 at the first band value. Then the second band value at color red, it is the value 2. So that means that the value is 0, 2, means that the value is only 2 because the 0 doesn't have any value. Then we will multiply it with the third digit, and the third digit equals to, the blue equals to 10 power 6. So we are going to times or multiply this 2 with the 10 power 6, and then we put plus or minus what we have. The fourth digit is a silver, and the silver equals to plus or minus 10%, and we will put plus or minus 10%. Okay, and the plus or minus 10% means that the value of this resistor equals to 2 million ohms, and plus or minus 10% means that there is a fault percentage equals to 10%. And also we can say that this is 2 plus or minus 10% mega ohms, because the 1 million ohm equals to 1 mega ohm. So these 2 millions ohms equals to 2 mega ohms. So the value of this resistor equals to 2 plus or minus 10% mega ohms. And we have the 5-band resistor. The 5-band resistors, the second type of resistors, consist of 5 bands or 5 digits. First digit and the second and the third has the same value, like this. So we put the first, the second and the third band of the resistor, the value of these 3 bands of the resistor. The first band is black, so the value of black is 0, so we are going to put 0. Then the second value or the second color is red, and the value of the second color is 2, so we are going to put 2. Then the third digit or the third band equals to, or its color is green, so the value of the green is 5. So then we have 25 of the first 3 bands. Then we are going to multiply it to the fourth band. So the fourth band equals to yellow, or the color of the fourth band is yellow. So the value of yellow is 10 power 4. So the value of this resistor is 25 multiply or times 10 power 4 plus or minus. We have the fifth band is a blue, and the blue in the fifth band of the 5-band resistor equals to it also a tolerance, and this equals to plus or minus 0.25%. So now we have the value is 25 times 10 power 4 plus or minus 0.25%. So that will equals to the 25 times 10 power 4, it will equals to 2500 ohms plus or minus 0.25%. And that also will equals to, we know that 1000 ohms equals to 1 kilo ohm. So we are going to say that this number equals to 250 times 1000, and we will cancel this 1000 and we'll replace it with letter K, or kilo ohms. So that will equals to 250 plus or minus 0.25% kilo ohms. So this is the value of this resistor. We can also use a much easier way to calculate the value of the resistor. This way is by using an apps or applications. These applications are, we can find it on App Store or Play Store on your smartphone. So that means that we can also use a program or applications to calculate our resistors value. There is a famous application. This application exists only on the Android phones, and called Electrodroid. This Electrodroid is a very useful application. We calculate from it the value of the resistors. The variable resistors. The variable resistors is the fourth type of the resistors. The last type of resistors is the variable resistor, and that type consists of two types. First type is the trimmer. We can set its value using a screwdriver. So we have the variable resistor. This is the trimmer type of the variable resistor. The variable resistor is a normal resistor, but we can control its value or change its value using, for example, a screwdriver at the trimmer type. This type is a resistor that we can set its value using a screwdriver. And the second one is the potentiometer. The potentiometer is a variable resistor, a resistor that we can set its value, the resistance value of this resistor, using our hands to rotate this pin. Okay, these three are potentiometer, and this is the trimmer. Symbols of resistors. These are the symbols of the types of resistors. We have the first type. This is the symbol that exists in the circuit diagram of that we use to design our circuit. First type is the normal resistor, and this is its symbol, and this is its shape on the real life. We have also a power resistor used to dissipate high power. This resistor used in high power devices. If we have a high power device that consume high power rating, this is its resistor that we will use. It has the same symbol of the first resistor. We have another type of resistor. This type of resistor called LDR, or light dependent resistor. This light dependent resistor is a normal resistor, but it changes its value depending on the intensity of the light. We are going to explain this resistor afterwards in I guess next lectures, and this is its symbol, and this its shape in the real life. We have the variable resistor. This is the symbol of the variable resistor, this symbol or this symbol, and these are the shapes of the variable resistors. That's it in this lecture. Thanks for watching, and I hope to see you in the next lecture.